At 2 minutes after 6 p.m. on December 18th, 1958, a team of Convair-Astronautics engineers and technicians placed into orbit around the Earth the majority of an Atlas missile. This is a model of the missile which was placed into orbit. The missile is the same as that used for military purposes. The missile is launched vertically, and after a few minutes of flight, the booster section, consisting of 2 engines and this thrust structure, is jettisoned, the remainder of the missile continuing on along a trajectory which places it into orbit. This is a model, an actual representation of the part of the Atlas missile which was placed into orbit around the Earth. This is the only missile available at the present time, so far as we know, which is capable of placing itself into such an orbital trajectory. The 1.5 stage technique which I just described is one of the reasons for this being possible. The missile was placed into orbit using the guidance system which was designed in order to provide the proper trajectory for use as a ballistic missile against surface targets. The launch procedure was very well conducted on this particular flight, as evidenced by the fact that the actual launch was only 2 minutes after the time scheduled many hours before.
T-minus 5 minutes. Mark. All communications switch to channel 1.
How's she look, Freddie?
3 minutes, 50 seconds. T-minus 3 minutes. Mark.
Dumping LN2, starting flight pressurization. All meters are covered. How the tanks look, Jack? Look good. Ready to start. Ready to start.
Minus 10 seconds. 5.
And now, Kraft Ehricke, assistant to the division manager of Convair-Astronautics, will tell you something about this satellite's orbit and its implications with regard to the future of space travel.
Following its takeoff from Cape Canaveral at the Atlantic Missile Range, the Atlas vehicle was delivered into orbit at the nearest point to the surface of the Earth, which we call the perigee. The velocity which the vehicle had at this point was greater than required to maintain the same altitude above the surface from then on in a circular orbit. Consequently, it went into an elliptic orbit, increased its altitude until it reached its most distant point from the Earth, which is called the apogee. The orbit of the Atlas satellite is therefore an ellipse. It is inclined with respect to the equator by an angle of about 32 degrees. Its closest point, the perigee, is at an altitude of about 111 nautical miles. Its most distant point, the apogee, is at an altitude of about 920 miles. This apogee lies approximately over the Indian Ocean, the perigee approximately over the West Atlantic. It takes a vehicle about 106 or 103 minutes to complete one revolution. The launching was made from Cape Canaveral during this flight in order to be able to take advantage of the rotational velocity of the Earth. If we would have launched the vehicle from the new Pacific Missile Range at the west coast here, we would have been forced, for safety reasons, to go into pretty much of a north-south orbit. The vehicle would therefore have been not in a moderately inclined orbit with respect to the equator, but it would have been in what we call a polar orbit. And we would have not been able to take advantage of the rotational velocity of the Earth. Now, the significance of this particular firing lies in the fact that it demonstrates most dramatically the reliability of the Atlas vehicle. Since this was the first time we tried this, and we've been successful, it furthermore had a technical significance as far as the intercontinental ballistic missile firings are concerned, because firing a vehicle into an orbit gives us a better chance to check the guidance system's accuracy than a regular long-distance flight, which lasts only 40 minutes. We have to make all our measurements within those 40 minutes. While here now, in this orbit, which may last as long as 14 to 20 days, we have plenty of time to make additional measurements on the vehicle and establish the accuracy of the guidance system which delivered the vehicle into the orbit. Thirdly, the significance of the firing lies, of course, in the fact that it brings manned spaceflight one step closer. The Atlas design has been explained to you before, and you will remember from those explanations that the Atlas vehicle only drops its two booster engines together with the rear skirt. Therefore, it delivers its entire tank structure into an orbit. We knew this from our theoretical calculations. However, it's of course most valuable to have this proven by the actual practical accomplishment. I had the chance earlier this year to speak before the National Press Club and explain to them a scheme for introducing and building the first manned space station, a small experimental space station. This scheme made particularly use of this quality of the Atlas vehicle to fire its own tank into an orbit. It assumed that the tank would be fired into orbit and subsequently properly equipped for approximately 4 people to live there over a greater length of time, such as a week or perhaps a month or even several months. This little model here displays to you the particular installation that is possible in the Atlas tank after the tank has been delivered into orbit. It was not too long ago that schemes like this were considered fantastic and unbelievable. The fact that the Atlas has been launched with its complete tank structure into an orbit, and that it could be observed for a while after it was in orbit, is proof that these things are not fantasy. They are reality, and they represent a significant step further in the realization of the space age. The Air Force Atlas program is managed by the Ballistic Missile Division, Headquarters, Air Research and Development Command. Associated with Convair Division of General Dynamics Corporation on Atlas are the Rocketdyne Division of North American Aviation, General Electric Company, Burroughs Corporation, and Sundstrand Turbo Division of American Bosch Armor Corporation. This test was one of a continuing series of research and development flight tests of the Atlas weapons system.